Well, thank you for coming today. It's actually not such a small group, but it is a big room. Let me ask first, though, how many of you were at the session yesterday on climate change? Or maybe I should put it the other way, how many were not? So just a few. So we should keep that in mind, I guess. And most of you, I presume, were at the plenary this morning and heard about. So this is the third sort of climate change session. I'm wondering whether we're right at the edge of, going to informality instead of formality with my presentation. Why don't I try, if you'll allow, being informal, and maybe I'll pick out appropriate slides at the right point, rather than, going through. Does anybody here doubt that climate change is happening, or that the Arctic is getting more of it? No, please be honest. If you think that we're critical scientists and have to want to treat the evidence critically. What about that it's human caused, mostly, the climate change? Okay, so there's a couple of people who still have some doubt there, but you're not doubting that you're seeing some climate change. Pardon? You do think it's, oh, okay. Anybody not think it's caused by humans? Sorry. So we're all on the, on that side of things here. And let me start by saying that if you're not familiar with the IPCC, I mean, I know you've heard of it, seen some of the results, but if you're really interested, spend a couple hours going through the website. There's really a tremendous amount of information. And they've laid it out in different ways. You can download the chapters, you can download the summaries, the technical summary, the policy summary. You can download the figures separately or together. You can look at various press releases and short summaries of other kinds. It's a very valuable resource if you're ever making a presentation or trying to convince your brother-in-law or something in this field. I might say, since I think Chris and I have been much involved with these assessments. She actually more than me, or for more in depth. But I won't speak for her. But I say, they're underutilized. I mean, there's a huge effort. There are 800 scientists as lead authors in the recent IPCC assessment, and a couple of thousand others in various other capacities, contributing authors or reviewers. It's a major set of actions that had 3 permanent or full-time paid technical backup units, one for each working group. Working groups, again, to remind you, working group 1 is the climate science. That's what gets most of the media attention because, of course, the concern is what's going to happen in the future, what's the temperature rises. Most of the graphs you've seen on those things come out of that working group. Very important, and it's, it has to inform the other working groups. No use looking at an effect, right? For example, in working group 2, which is mainly on effects, also on adaptation. No use working on an effect if working group 1 says it's not going to be happening. Is it? Or is it? This is one of the issues, I think, because actually working group 1 identifies a whole set of things that they're not so sure are effects yet, like drought and an enhancement of tropical cyclones. Yet, let's keep the yet in climate change. They're being very critical. They apply some very strict criteria. We can talk more about that in a second. But they identify some things they say is unequivocal. Heat, mainly almost anything you can think of related to heat. Number of hot days, number of warmer nights, heat periods of heat, heat waves, average temperature, ocean temperature, land temperature, Arctic temperature. All of those things are, very clear, highly likely from human-caused climate change to date. But when you get down to the next set of things, droughts, tropical cyclones, heavy flooding events, they're much less certain that we're seeing something today. And yet there's much of the health science, not to mention other types of impacts on agriculture and energy use and the oceans and so forth, that that does assume that the droughts are, we may be seeing more droughts, but the question is, are they caused by climate change? Now, it raises an issue. I mean, it was actually a dilemma for us. I was the meeting lead author in Chapter 11 in Working Group 2, which is the health impacts, adaptation and co-benefits chapter. We have, for example, one of the things that Working Group 1 was pretty clear. They said very clearly, actually, they couldn't even tell the sign of the impact of climate change on particle air pollution. Couldn't even tell it was going to cause less particle air pollution or more particle air pollution in the world. Now, particle air pollution is a big health problem, generated mostly by human activities, but those are, sort of separate from climate change. And particles do interact with the climate. Some are cooling, some are warming, and it gets more complex than that. They seed clouds and various things that have an effect on climate. But the summary statement was they can't even tell the sign. Yet, got a lot of colleagues in the air pollution field who publish studies showing the health effects of climate through particle air pollution. So what do we do with that? Our job was to review the literature, and that's part of the literature, published and peer-reviewed in good places. But it doesn't fit what, over in the other room, so to speak, or over in the other city, Working Group 1 was saying. And in some extent, society was expecting us to have an integrated assessment, where what came out of Working Group 1 was then reflected in Working Group 2, which was then reflected in Working Group 3, which is, the mitigation, what are we going to do about this? But of course, those literatures don't develop, in an integrated fashion. They develop independently, basically. The climate scientists never read Lancet, I'm sure. And the Lancet readers don't read, geophysical letters. So it's not integrated. And we can't, 11 of us as lead authors in the health chapter can't integrate it in the process of, a few meetings and drafts of things. And that is a dilemma, and it's pretty big I would say, in my mind, and something I struggle with still. I mean, in one sense, we say we have to move with the scientific assessments. We did this huge effort. We spent many tens of millions of dollars. We get the best, combination of scientists to do this assessment. We run it through as, very extensive peer review. I think in Working Group 2, we had 55,000 peer review comments. Just in the health chapter, we had, I don't remember, 2,500 or so. We had to write a response to each comment. You can actually download those comments from the IPCC website. There's a spreadsheet, shows each comment, who wrote the comment, and our response. Some responses were fairly detailed, others were, thank you for your comment, but anyway, there was some response we had to put there. Well, that's a pretty transparent, system, actually. Compared to, many, I don't think many journals would do that, or do that. So that's transparent, but how do we deal with the fact that the sort of the disconnect, if you like, even within the field between what the climate scientists are saying we can actually attribute both to climate change and, secondly, to human-caused climate change. Now, they actually have a set of terms for this. It's called detection and attribution. And this is where I want to start talking about the links with epidemiology as I see it. The detection and attribution is, there's got to be a sort of DNA. That was the, got to be a jargon. It got to be the sort of way that Working Group 2 interacted with Working Group 1. And so they're looking for, what does that mean? Detection, it means, well, are you seeing a trend, let's say, of droughts that is exceeding the natural trend? Without attributing it to a particular cause, but are you seeing a trend? And I see that in epi terms as, as a sort of, hypothesis testing, as the relative risk, and with confidence intervals exceeding, some confidence intervals, say 95%, that a particular thing is different than something else. The trend is different of droughts compared to some baseline. Now, you can imagine the science behind that is very tricky. Droughts go up and down, different parts of the world, big droughts, little droughts, long droughts, short droughts, very heavy droughts, not so heavy droughts. A little tricky to put all that together into some sort of trend line, particularly in a world in which the data is a lot different 20 years ago than it is now, data collection and so forth. Then, if you say, well, we have detected a trend in droughts, can you attribute that particular trend to climate change? I mean, to human-caused climate change. Now, there are effects on the climate that are not human-caused. You know, volcanoes, natural variation, solar radiation, all sorts of things. It's thought overall that those, except for volcanoes, which are just, you know, temporary things, they don't really don't explain very much, maybe 15% of the overall changes. But what about a particular thing like droughts? So, in the answer to the drought one, I can show you with the Working Group 1 summaries, they basically say they're not so sure there's been a trend of droughts or that you can attribute what they do see to human-caused climate change. Then there's the question of where you're talking about. Globally? I mean, you know, people don't experience drought globally, they experience it locally. So what about the droughts we do see? And, you know, I mean, we have a drought in California now, I mean, or, you know, Sub-Saharan Africa or Australia or wherever. Is a conclusion about the global trends really the relevant question? Certainly for health, people don't experience, you know, health impacts globally exactly. They've experienced, you know, it's the local. So this is actually, you know, a difficult thing that it involves a lot of different kinds of thinking. I mean, in the DNA, in fact, we felt that you couldn't really say much about health effects today from climate change. Now, it doesn't mean, you know, in Alaska, where you get very large temperature changes, you aren't seeing things. So what do we mean by health effects? I mean, we find one health effect in one place. I mean, let's say this Vibrio, you know, event. Vibrio H, I noticed they did V and then they pronounced the second word. I'm going to pronounce the Vibrio and put an H in the last word. Okay, maybe you say that's definitely climate change. But is that enough to say that climate change is causing ill health globally, one effect in one place? Well, yes, at one level. We don't want anybody to get sick. But, you know, that's not really, you know, not much to tell a newspaper. How much of local effects have to build up to a global effect? Now let's be a bit cynical or critical, as we might in other kinds of things. How many people publish papers saying, well, we looked and climate caused no effect? What kind of publication bias is going on? One of the iconic figures from the previous assessment, I have it in here, but is a big map. It was in the summary for policymakers. You see it reproduced a lot, and it shows observed events that were consistent with climate change. And these were things like spring coming earlier, the birds, you know, arriving earlier or leaving later, or, you know, various the rainfall patterns being different or something. The whole range included a range of things. You know, and I don't remember exact numbers, but something like 30,000 were shown, you know, were consistent with climate change, and then, you know, 400 were consistent with no climate change. All right, now personally I believe there's climate change occurring, but those numbers aren't very convincing. How many people publish a paper, oh, I looked out you know, my window. First of all, these are all convenience samples, almost all convenience samples, literally, and sometimes in people's backyards, you know, when the birds arrived. It wasn't a systematic survey of the world, you know, taken randomly and then check, and then you publish what you found, no matter what you found. And if you look out your window and the birds arrived the same day they did last year, do you publish a paper? I mean, the publication bias must be dramatic. No funnel plots. Those of you know systematic reviews and meta-analysis in epidemiology. I bet if you did a funnel plot, you'd find, you know, all the little ones, you know, were in one direction, and the big ones, you know, were the ones that matter. Because, well, but there aren't that many big ones for that kind of thing. So, I mean, these are, you know, this is a set of issues associated with observational science, right? We basically, this is the ultimate observational science. We have an N of 1, the Earth we're sitting on. We're not going to have, you know, a larger sample size. We have to do detection and attribution with an N of 1. Now, but, you know, I think health people have thought a lot about observational science. I mean, there are a lot of things that we look at that we can't do experiments. There are a few, randomized trials we can do, required for drugs and things. But, look at the biggest single probably health effect in the world, depending on how you measure it, is, sticking burning stuff in your mouth, which a lot of people still do. Smoking. We haven't done randomized trials with smoking. We're never going to do randomized trials with smoking. You might have gotten away with it 50 years ago. You couldn't get permission now to do it. But does anybody doubt the causality of smoking and ill health? I don't think so. Certainly not in this crowd. Why? Why do you believe it? No randomized trials. Maybe people are going to get lung cancer, start smoking, right? That's what the cigarette companies used to say. Well, observational evidence can be very powerful, particularly when it builds up and builds up and builds up. We see every single possible endpoint you might think of, in study after study. You see tens of thousands of studies, done by thousands of investigators in hundreds of countries, multiple times, different age groups. It starts to be kind of convincing, even though there's no randomized trial. And then it's backed up by the toxicology. We know there's nasty stuff in smoke that will cause changes to tissues and, precursors to mutagenic and so forth and so on. Exactly the same in climate. We don't have any randomized trials. We're not going to have any. But we have multiple observations by thousands of investigators all over the place, on, glaciers, and now other things could be causing glaciers. All right, but we also have it on spring coming early. Okay, we also have it on, waterborne outbreaks of this and that. We also have it on sea ice. You go down the list, all the observations. These are the, and then it gets to the point, okay, if it's not climate change, what is it? What else could be causing all of this? All right, changes in the Earth's orbit. Examined carefully, dismissed. Changes in solar output. Examined carefully and, fairly low part of this thing. So you get to the question, you have all this observational evidence and no other possible explanation. And also we have toxicology. We call it atmospheric physics and chemistry. It makes sense from the physical processes that greenhouse gases would heat things up and they would have these, certain impacts. So we have a great deal of observation across lots of different types of outcomes and lots of different investigators in different places over time. And we have toxicology, if you like, or the physics, basic science that backs it up. But at one level, of course, it's not proof. But proof is, pretty slippery term, and besides which, this is the planet we live on. We've got to protect ourselves, when most of us would think we have well enough evidence to try to do something about, as we do with cigarettes. Now my original field was astronomy, actually, and if you talk about a science that can't do experiments, astronomy is about the, and we are doing an inadvertent experiment with our planet, but you can't do experiments very well with, intergalactic particles. So you're really stuck with observational science in astronomy. So is geology. So is much of economics. There are actually a lot of other important fields, with a lot of smart people looking for a long time who are trying to struggle with detection and attribution, if you like, attributing causality to observational data. So one of the proposals I had, in which I noticed that there's a session at the end of the day here at the meeting. What is it they call it? Somebody from the IEA, it's the IEA Congress of Causality, or some such grand title. What is it called? The World Council on Epidemiology and Causation. Yeah, okay, a World Council on Epidemiology and Causation. Well, why not a World Council on, observational data and causation? Then bring in the astronomers, bring in the economists and the econometricians, bring in the geologists. The gene people are doing it. It's this hypothesis-free, they call it, sometimes called hypothesis-free investigations, using large data sets. Well, climate actually shares this problem with, and I think the health field has actually thought about this perhaps more than the other fields have, with our causal inference work and some of, our brilliant people who work in this area, Sandy Greenland and so forth. that we could have formed those other groups. We can tell them about funnel pots if they don't know about them, and we could help in this. And these are, I mean, maybe astronomy isn't so much affects human affairs, but some of these other fields certainly do, and they need to get a better. And it's a little bit relates to Tony McMichael's comments yesterday about, you know, how do we look at this at the systemic level, the very large scale, and then we still have to think about causality, and we're not going to do it, so narrowly as we've been able to for a drug or, you know, particular risk factor, or particularly one that you can randomize and do a controlled experiment. So now this is an aspect of that I think epidemiology can interact positively, provide some help, if you like. Now another thing that we got a lot of pushback, if you want to look at through our references, I mean our review comments, and then even afterwards, we published a short summary in Lancet about them, is, you know, where's your systematic review and meta-analysis? Well, first of all, of course, it takes a lot of resources to do that, and there weren't many resources available to us, except our travel. Secondly, you know, it's very hard. I mean, it's not like, a drug or something where you have a sort of very simple set of exposure metrics and a simple set of outcome metrics. I mean, that's a huge variety of things. And so we had to say we didn't do anything. I mean, we searched the literature. That was our job. Actually, our job was mainly searching the literature since 2007, the previous review. And even in that relatively short period of time, 2011 to 2013, I mean, there was a huge increase in the number of papers, just in health. I mean, remember the numbers, but thousands. And in reality, you can't read them, even read them all. Even dividing up the tasks among our, committee and then the contributing authors. I mean, Chris was a contributing author, unfortunately for us, on adaptation. But, even the guy who was doing vector-borne disease, he couldn't read all of those papers. He could really look at the abstracts. I mean, it wasn't a systematic review. It's an assessment, a judgment. But that's not entirely comfortable to everybody. Of course, and I don't know the answer to that, whether you could ever really convert this vast variety of endpoints and, metrics and styles of, types of investigation and so forth into any kind of systematic review, let alone a meta-analysis. I don't know the answer to that. And then there's sort of Tony's implied question, do we need to? I mean, is that really the right approach? Are we going to ever come up with a relative risk for climate change and vector-borne disease, 2.6 plus or minus X? No, I think the sort of having to answer that question in a sense is the answer no. It's not really, wouldn't be valuable even if you could simplify things down to be able to do it. But people in our field, expect this. So they, if it's not systematic, then it's biased, almost sort of by definition. Yes, I guess it was biased. It was biased by the opinions and the expertise of these 11 people that were the lead authors on Chapter 11, with their contributions from contributing authors. And those 11 authors were good people, but they were not the world's, they weren't a random sample of the world's expertise, which raises another issue. If you look at those 11 authors, there was, you might say, many people would say, fortunately only one North American, me. And there was a Russian and, South African and a Chinese guy and a fellow from Japan and Alistair's from New Zealand. Kind of a spread around the world. But I don't think you could say, none of us would say, we were the absolute 11 most, capable climate health scientists in the world. No. But that wasn't, the choice. I mean, actually, I should let Chris talk about this more, how the choosing these authors came about. And we did get pushback on this from reviewers and also in the Post, in the Lancet articles and so forth. You're going to tell me when I'm running out of time. Okay. Yeah. But, you also have to find people who are smart enough to know something about their literature, but dumb enough to get involved in one of these assessments. because it's a huge effort. Those of you who've been involved in it know, and particularly, I must say, I didn't realize how much difference there is between being a lead author and a convening lead author. Huge effort of time, not compensated directly anyway. Of course, my university paid my salary, so you might sense. And that's another interesting, you know, if you change the system boundaries or sort of think the framing of it, the huge subsidy that went from all of our institutions of the people involved in this, because the IPCC had money for, well, or gathered some money for the travel, the meetings and things. And we had 5 meetings, 5 author meetings. These are big affairs with, well, one in Japan and one in Argentina and one in Slovenia and so forth. Everybody comes together for 5 days and hammers out their thing and interacts with the other chapters, the agriculture chapter and the urbanization chapter and so forth, to try to integrate a big investment of money just in the travel and organization, but of course even bigger investment in people's salaries that were being supported by their own institutions in some fashion. So, and then it burns people out. Certainly. I mean, some people, myself, I don't know what you'd have to do to get me, or to do another one of these, or to get my wife to agree. So, but maybe that's good, you move on to a different set of people. And also serves, I must say, as a capacity building effort. Some of these scientists in the team, were, not, well, they weren't senior in age and hadn't been engaged in these international assessments before, and so they go home with a build-up capacity and how to think about these. This is actually a very important contribution, but it means you don't get the 11 top climate and health scientists in the world sitting there. First of all, many of them wouldn't do it. Even if you ask them, they tend to be from a small group of countries. They tend to have certain ages and sexes associated with them. And also, there was a gender balance, of course, on the committee and so forth. So that's, but I think most of us feel that actually, that trumps getting the best possible expertise. That there was a spread of disciplines, spread of ages, spread of, both men and women, and most importantly, I think from IPCC's standpoint, the spread of regions. But then, of course, we didn't have an Indian, Good Lord, get 11 people and no Indian. I mean, you get complaints from India about that. So you can't win entirely. We certainly didn't have anybody, didn't have an indigenous person from Alaska on the meeting. Arguably, it's not a stakeholder. They were not stakeholders. Not stakeholders. We look like, you certainly ought to have somebody from, at least a little Pacific Island or something, somebody that's right at the spear point of the effects if you're going to have stakeholders. And there was nobody like that on our committee. You might have some knowledge of it, but they weren't, personally part of a group that was highly vulnerable. None of us are going to have any impacts of climate change on our health. But of course, trying to understand it more broadly. And let's talk about another framing issue. And I did, but I see there's more people here now, and it's an issue I mentioned yesterday, is that when epidemiology is basically backward looking, right? I mean, you look at a set of data, might be a cohort you're following, or, existing secondary data set or something, but it's backward looking. You're looking at, and the comparative risk assessment of the global burden of disease, which I'm not going to talk too much about, but that's backward looking. It's just basically as how much less ill health there would be today if nobody had smoked in the past. How much less ill health there would be today if there had been no air pollution in the past, or whatever. But of course, that's interesting and valuable, but it's not really the point here, right? It's particularly for climate change, since there hasn't been that much in the past, compared to what's going to happen in the future. In fact, if there was climate change that stopped today, where we are now, we wouldn't, it wouldn't be a session like this. It's the future that matters. Well, epidemiology isn't well set up exactly to do future stuff. I mean, first of all, you control all the covariates, right? If you're going to do let's just pick something relatively simple like air pollution. You look at the covariates of other risk factors for let's just pick heart disease. For heart disease, there are a lot of covariates for heart disease. Nutrition and so forth and so on. Smoking, of course. You do though, you control those backwards with your cohort, and you get an answer. This is how the great studies have been done on air pollution, 6 studies and so forth. But that's not what we're doing. We're looking forward. Well, how do you do with those covariates going forward? If there's a lot of smoking in the future, you get one result. If there's not a lot of smoking, you get another result. If people's blood pressure goes down or up, their cholesterol, whatever, all of these things are going to change the burden in the future. And the future is harder to predict than the past, I guess, is what I'm saying. And so past is hard enough. But it depends on your vision of the future at some level. The baseline or the counterfactual, or whatever you want to call it. Now, your vision of the future is, partly you can model. You can look at this trend of X or Y and, model it out and, use that. But it's also depends on your sort of, I don't know what you call it, your optimism about the future. And a big part of that is economic growth. Economic growth, as I mentioned yesterday, is a major impact on global health. We've had major improvements in global health in the last 40 or 50 years in the world. Maybe not in individual places, of course, necessarily, but in the world.